one of the interesting areas in mathematics. However, sketching a curve with the help of GDC is quite easy, but without GDC it becomes complicated sometimes. So for sketching a curve without GDC, we need to know the following points about the nature of the curve. Number one, what are the stationary points of the curve? Means where the curve takes turns, maximum or minimum or inflections. Number two, where the curve is increasing or decreasing on a given set of or on a given interval, we can say. And number three, what is the concavity of the curve, where it is concave upward or concave downward. We'll use the idea of derivatives, first derivative and second derivative. Let's take an example. Given curve is negative x cubed plus 9x squared minus 24x minus 7. So by the use of understanding of the derivatives, we aim to sketch the curve. First of all, we write the curve as it is, then we differentiate it. The gradient function is given by negative 3x squared plus 18x minus 24. We equate the gradient to 0 because we are searching for the stationary points where the curve takes turn. So where the curve takes turn, the gradient at that point of the tangent is always 0. For stationary points, we equate the first derivative to 0 and we write the values of x for which the first derivative is 0. So we find that x is equal to 2 and x is equal to 4 are the points where the curve takes turn, but we do not know whether these points are maximum or leading to a minimum. So we'll take the help of sign diagram of the first derivative. At x is equal to 2, we can use the first derivative test and we can see that the first derivative on the left side of 2, if we put 1.9, the first derivative will be negative. On the right side of 2, if we put x is equal to 2.1, the first derivative will be positive. So gradient changes sign at x is equal to 2, and similarly the gradient changes sign at x is equal to 4 from positive to negative. At 2 it changes sign from negative to positive, so therefore the x is equal to 2 is the minimum point, x is equal to 4 is the maximum point. I mean not point, but the coordinate of the maximum point. So by substituting these values, x is equal to 2 in the given curve, we get negative 27 as a minimum point, and x is equal to 4 in the given curve, we get negative 23 as a maximum point. So for increasing and decreasing nature of the given curve, we again will use the first derivative, the sign diagram of the first derivative. We can see at x is equal to 2, or on the left side of 2, or we can see the gradient in between 2 to 4 is positive, so that we can say that curve is increasing on this interval. However, for x less than 2, the gradient is negative, and for x greater than 4, gradient is also negative. So we can see that the gradient is negative on negative infinity to 2 and 4 to infinity, so we can say the curve is decreasing on that interval. Now for inflections, we need to have double derivative. We equate double derivative to 0 and we get the value of x, that is 3. Now we use the double derivative sign, or we can first check that first derivative at 3 is non-zero. And now we can use the sign diagram of double derivative to confirm the concavity. Double derivative changes sign from positive to negative, and first derivative at this point is non-zero. Double derivative is 0. When double derivative at a point is 0 and first derivative is non-zero and double derivative changes sign at that point, we call that as a non-stationary point of inflection. So x is equal to 3 leads us to a non-stationary point, that is 3 negative 25, non-stationary point of inflection. Now since double derivative is negative at x is for all the x greater than or equal to 3, so therefore curve is concave downward for x greater than or equal to 3. However, double derivative is positive on the left side of 3, so curve is concave upward for x less than or equal to 3. Now we have sufficient information to sketch the curve. We can see, if possible, we can mark the y-intercept from the curve so that we can sketch the most appropriate curve. Let's sketch the curve manually. With the required information at hand, let's sketch the curve. We have already explored maximum, minimum of the curve, non-stationary point of inflection, increasing and decreasing intervals, concave, upward and downward intervals. And we also have the y-intercept of the curve. So let's start with marking first the maximum point. Maximum point is 4 negative 23. So let's mark 4 negative 23 first. 4 negative 23. And then we have minimum point 2 negative 27. So 2 negative 27 is somewhere over here. Now the curve is concave downward for x greater than or equal to 3. We should mark the stationary non-stationary point of inflection also. So we have a non-stationary point of inflection at 3 negative 25. So from this point to the right side, the curve is concave downward, freehand, and to the left side of this point, the curve is concave upward, and we can join these points freehand. We can mark the y-intercept also for more accuracy, and then try to join freehand, and the curve will be somewhat like this. Now we can see the curve is increasing on interval 2 to 4 here, that is interval 2 to 4, that is interval 2 to 4, increasing curve. X increases, y also increases on this interval. And on the right side of 4, if we look at on the right side of 4, from this point onwards, that means 4 to infinity. On the left side of 2, that is over here, the curve is decreasing, negative infinity to, we can mark it like this properly, negative infinity to 2, and their union tells us about the decrease in the curve. Curve is decreasing from negative infinity to 2 and 4 to infinity. And here, this point we have is a non-stationary point of inflection, from where we can decide the concavity of the curve at this point. Y-intercept, that is point D, point A, we can say minimum point, or we can say A is the maximum point, B is the minimum point, and C is the non-stationary point of inflection on the. We can label the curve. We can label, we can title also. So that is always helpful if we have appropriate labels on the curve. Thank you.